Hello everyone, welcome to today's class. This is Teacher Simon taking you through AS Pure Mathematics 1, paper 9709 stroke 12 for May, June 2025. And this is part 2 for questions from 7 to 11. Question 7 is coming from trigonometry, but A, they are saying prove this identity, that this one here is equal to that. Okay, now if I can begin from the left side, remember you can begin from the right, you prove the left, or you can begin from the left and then you prove the right. You see, so if I begin from the left here, tan, we know that it is the same as sine over cosine, so I can say sine theta over the cosine of theta. Then here there is a 7, then we say out of, this is again sine but then squared, out of the cos squared of theta, then minus 3. We need to get one fraction here and then one fraction here. Okay, so cos theta times the 7, you will get 7 cosine of theta. Okay, then out of the cosine of theta, then here we shall have sine squared theta, then minus 3 cos squared theta, then out of cos squared theta. So meaning I can get sine theta, then plus cos 7 cos of theta out of the cosine of theta. Then we multiply by the reciprocal of this one, which will be cos squared of theta. Then we divide by sine squared of theta minus 3 cos squared of theta. You see that? Now one cosine here will cancel with one cosine there, and we shall remain with sine theta. You get that? Then that sine theta, actually one cos theta remains here, so which will multiply with everything here. So we shall have cos theta now times sine theta plus 7 cos of theta, and then down here we shall have since here everything is in terms of cosine, I'll use the Pythagorean identity. Sine squared theta plus cos squared theta is equal to 1. So that means sine squared theta is 1 minus cos squared theta. Then there is this minus 3 cos squared theta. You get that? Okay, now if we open the brackets here, cos times the sine, we shall get cosine of theta times the sine of theta, then plus 7, then cos squared theta. Remember, we are opening the brackets. And then down here, we shall have 1 minus 4 cos squared of theta. You see? And if you can observe very well, this is exactly what we are having up there, what they have told us to prove. You see the denominator? 1 minus 4 cos squared theta, and then up we have sine theta cos theta, then plus 7 cos squared theta. So that is that. Part B, hence solve this equation here. Now we know this one is tan theta. It was the left side they gave us, tan theta, then plus, was it 7? Yes, you see this one, it is all this one here. All right, so plus 7, then tan squared theta minus 3 as the denominator, tan squared theta minus 3. Then this one is going to be equal to 5 out of tan of theta. Now here we can cross multiply. We shall have tan squared theta plus 7 tan theta, which will be equal to 5 tan squared theta minus 15. Okay, take this one, this other side. 5 minus 1, you will get a 4. So we have 4 tan squared theta, then minus 7 tan theta. You get it? Then minus 15, which is equal to 0. So this is a quadratic equation in tan x, tan theta, quadratic in tan theta. Now, we need to solve this quadratic equation. Let's use the calculator and we see whether it is factorizable. Mod, then equation is 5, then quadratic is 3. We can put a 4 minus 7, and then minus 15. Yeah, it is factorizable. So we see a 3 and then a negative 5 over 4. So tan theta is equal to negative 5 over 4. And then tan theta is also equal to 3 there. Now, we need to show the examiner the attempt to solve this quadratic equation. So cross multiply here. You will get 4 tan theta. Then bring this negative 5 this side. It becomes a plus. So it is that. And then also bring the 3 here. We have to get the factors from which the roots come. Okay. So that will be tan theta. Then minus 3 is equal to 0. By doing so, you have already cheated the examiner, because this is an attempt to solve this quadratic equation, all right, using factorization method. And then from here, we are going to solve these two, but we can see that we have tan being positive and it being what? A negative. So all of them are positive in the first quadrant, okay? Only sine is positive in the second, tan is positive in the third, and then cosine is positive in the fourth quadrant. So here we have 90 degrees, 180, this is 270, and then by the time we come back here, this will be 360. And I've already said that when you are moving anti-clockwise, the angles are always positive. Then when you move clockwise, the angles are always what? Negative. Then if I can project here, let's say this is my theta, and then also this other side, opposite angles are always equal. So if this is theta, that means when you move from here up to here, that will be 180, then plus the theta. And then also if I put theta here, that means to move from here up to here, that will be 360. Okay, 360, then minus the theta. And then also if I continue this one here, then we have a theta. That means to move from here up to here to get the angle in the second quadrant, then it will be 180 minus theta. Okay, now we take this one here. We have theta shall be equal to the arctan of negative 5 out of 4. And then here, theta will be equal to the arctan of 3. Now, this one here is a negative. When you press this on the calculator, it is going to give you a negative answer. Okay? But then we don't have the domain of those negative answers. What we are having is from 0 to 180 here. Okay? Now, tan, what I always say, you ignore the negative, then you get that acute angle. Okay? Now, tan is negative in the second quadrant, and to get an angle in the second quadrant, we say 180 minus the acute angle. All right, so this one here is going to be equal to 180 degrees, then minus the arctan of 5 over 4. Okay, so we have 180, then minus what is this value? The calculator has to be in degrees because our interval here, the domain is in degrees, so I have to change that. Shift, then mod, and then 4. That is where we see 3 degrees. Now we have arctan of 5 out of 4. That one gives us 51.3. That is to one decimal place. Then when we subtract here, so when we subtract from 180, and then we shall get 128.7. 128.7. That is to one decimal place. How about this one here? This one is already positive, so that means the arctan of that 3 will give us the angle in the first quadrant. Arctan of 3, that is 71.6. 71.6. So this therefore implies that our theta is going to be equal to 71.6 degrees and also 128.7. And these are all to one decimal place. As simple as that. Question 8. The diagram shows the circle with equation x squared plus y squared minus 14x then plus 8y plus 36, which is equal to 0. And the line y is equal to negative 2. The line intersects the circle at the points A and B. The center of the circle is C. Part A, find the coordinates of A, B, and C. Okay, now based on what we are having here, since C is the center of the circle, then that means that I need to complete squares to find that center. Okay, so we shall have x squared, then minus 14x. I'm trying to rearrange such that y's are together and also x's are together. And of course, I can take this 36 to this other side. Now, completing squares, I'll get this one divided by 2. So it will give me a negative 7, put it in brackets with this x, then I pop it out as a square. Then the same to y, 8 divided by 2, you'll get a 4. Then pop it out as a square. Okay, and then this one is equal to negative 36. So that means we are going to have x minus 7 squared, then plus y plus 4 squared, and then we shall have negative 36. Then we add on this 16 and then the 49, right? So plus 16, then plus 49, meaning we shall have x minus 7 squared, then plus y plus 4 squared. Now this one will give us negative 20. Not so? Yes. If it gives us negative 20, then plus 49, that one will give us, it's like 49 minus 20. That one will give us 29. Not so? So this therefore implies, remember, if we compare with x minus a squared, then plus y minus b, comparing with the general equation of the circle, which is x minus a squared, then plus y minus b squared, which is equal to r squared, where this one is the radius and this is the center. Okay, center AB. So we shall say therefore C, the coordinates of C being the center, 7 is that, and then this one here minus b is equal to 4. That means b will be negative 4. So we shall have 7 and then negative 4. Those are the coordinates of the center of the circle. As simple as that. Then they gave us this line here, AB, and they said it is y is equal to negative 2. That means when I solve these two simultaneously, okay, I can even use this one, no problem, whatever I want. Then I'll be in position to get the x values, okay? So I can say for x, no, I think it's not x, for y, which is equal to negative 2, okay? Then x minus 7, let me use this one here, but even if you use this, it is okay. Then plus, this will be negative 2, then plus 4 squared. This will be equal to 29. Now x minus 7 squared shall be equal to, this one here gives us, first of all, inside we are having a 2, then squared, that is a 4. Then we shall have 29 minus the 4, which is a 25. So meaning x minus 7 shall be equal to plus or minus the square root of 25. Not so? Whenever you take the square root, you have to get plus or minus. So meaning x here is going to be equal to 7, then plus or minus the 5 here. So that means your x1 is going to be 7 plus 5, which is equal to 12. Then x2 is going to be equal to 7 minus 5, which is going to be equal to 2. So that means A, when you look at our sketch here, our A is the one with the smaller x coordinate, and then B with the big x coordinate. So that means the 2 belongs to A. So I will say A will be 2, but then the y coordinate is what? Negative 2. So we shall have negative 2 here. And then B is the x coordinate, the bigger one is 12. The y coordinate is still negative what? 2. So that is what we are supposed to have here. You see that? Part B, find the angle ACB in radians. Give your answer correct to 3 significant figures. Okay, now when I come back to this one here, remember we have gotten coordinates of C, coordinates of A, and also coordinates of what? Of B. Now, the radius here is going to be root of 29, right? Because when we compare with this, the r squared is what is here. So it is root of what? 29. So I'll have root of 29 and also root of 29 here. It's a radius. Now, here what we are having, yeah, so our B is a 2, 12, negative 2. Our A is a 2, then negative 2. C here is 7, negative 4. Now, they want us to find angle ACB in radians. So angle ACB, this is the one here in radians. Now, do we know this length here, AB? Yes, we can just say 12 minus 2, which is 10, not so? So these are 10 units. So I can begin by saying length AB is equal to 12 minus 2, which is equal to 10 units. Now, we can see that all the lengths are known on this triangle. And if all the lengths are known, then that means we can use, the triangle is not right angled, so we can use SOHCAHTOA, sine rule or cosine rule. But for this case, we shall use cosine rule. So using cosine rule, we can have, remember, it is a squared is equal to b squared, then plus c squared minus 2bc, then cos of a. So we are going to have, we are looking for this angle, okay? So cos of that theta, cos of angle ACB, then is going to be equal to these two sides that are forming that angle. So we have root of 29 squared plus root of 29 squared, then minus the square of the side that is opposite to this angle, which is 10, okay? Minus 10 squared, then we shall divide by 2, then times the two sides that are forming the angle, root of 29 times root of 29. So meaning angle ACB then shall be equal to the arc cos of, this is 29 plus 29, that is 58, then minus 100. Not so? We get a negative 42, because 42 plus 58, that one gives us 100. And then here, this is 29, because root of 29 squared will be 29. Then times 2, that will be 58. Okay, so what will be the arc cos of this? The calculator here has to be in radians, okay? Shift, then mod, then 4. Now it is in radians. Now arc cos of negative 42 out of 58. That is 2.38 to 3 significant figures. 2.38. So 2.38 in radians, okay? 3 significant figures. As simple as that. Now, there is also an alternative approach to get this angle. Alternatively, we can do it like this. When we go back and we check here, this one is an isosceles triangle because this and this are the same. So I can divide this one into 2, okay? Then I can put theta here and then theta here. Now this one becomes a right angle triangle. Relative to this angle here, this one will be 5 units and this one will be 5 units. You see that? So this one here will be the opposite. Relative to this angle, this will be the opposite, and then this will be the hypotenuse. That means we can have sine theta. You see that? So we can have, let me draw a triangle here to be so systematic. This is A, this is B, this is C, this is root of 29, this is root of 29. Then since AB is 10, Then we divide this into 2 because this perpendicular distance from the center bisects the chord. This will be 5, and then this one can be theta, then this one theta. Now using SOHCAHTOA, because for a right angle triangle we can use SOHCAHTOA or Pythagoras theorem. Now relative to this angle here, like we said, this is the opposite and then this is the hypotenuse. So that simply implies that we are using sine. So sine of theta is going to be equal to the opposite, which is 5, out of the hypotenuse, which is root of what? 29. Meaning theta shall be equal to the arc sine of 5 out of root of 29. And therefore angle ACB is going to be 2 theta, okay? 2 theta. So we shall have 2, then the arc sine of 5 out of root of 29. Do we get the same answer? Let's see. 2 times the arc sine of 5 out of root of 29. Same answer, 2.38. 2.38, 3 significant what? Figures. Now in radians, when you for angles, when you just write something like this without the degrees, we consider the angle being in what? In radians. So whenever you are writing angles in trigonometry, if they are in degrees, remember to put the degrees. If not, we consider that it is in what? In radians. So but see, the chord AB divides the circle into 2 segments. Find the area of the larger segment. Okay, the larger segment, the chord is here, AB, which is dividing the circle into 2 segments. The minor here and then the bigger one here. So if I want to get the area of this bigger segment, you can see a triangle here, and you can also see what? This sector here, the major sector. So I will add the 2 areas. So I will say area of larger sector, larger segment, is equal to area of major sector, then plus area of triangle. You see that? Now area of a sector, remember it is a half r squared what? Theta. So this one is going to be a half, then r squared. What is the radius? Radius is this root of 29. So we shall have root of 29 squared, then times the theta. The theta for major sector is this one here. So this is the major sector. It comes like this. That means the angle it also subtends at the center of the circle is this one here. Okay? All right. Now, right from there, we can have, what are we going to have there? It is 2 pi, because angles at a point add up to 360. So we shall get 2 pi, then minus this 2 theta. So 2 pi, then minus 2 theta. So twice of this one here, 2.38. No, ACB, not twice of theta is the one that we got here. Okay, so that is that. Then area of the triangle, which is not right angled, it's a half. You have a triangle here, it is not right angled. If you know this, and then the angle in between, then it is a half. A times B, then sine of theta. You get that? Now that means we are going to have a half, and our triangle here, we can see root of 29, and then the theta here. So root of 29 times root of 29, then sine of this angle we have gotten, which is 2.38. 2.38. Okay, now I'm going to put everything in the calculator, and then I write my answer here to 3 significant figures. Now root of 29 squared, that will be a 29, right? So we are going to have 29, then it will multiply with the 2 pi inside here minus the 2.38, but down here we are having a 2, okay? Then we also have this one here, root of 29 times root of 29, that is 29, then sine of 2.38, then down here we are having a 2. So we are getting 66.666, then 0.6. That is centimeters squared. These are three significant figures. That is that. Question 9. The equation of a curve is such that the second derivative is negative 24 over x cubed. It is given that the curve has a stationary point at negative 219. Part A. Find an expression for dy dx. Now remember, this second derivative here is the derivative of the dy dx. That means if I want dy dx, then I will integrate this second derivative. You get that? Okay, so we shall just write here that dy dx is equal to the integral of this negative 24, then x to the power of negative 3 with respect to x. Increase the power by 1, it becomes a negative 2. Divide by that new power, but we need to put an arbitrary constant here because we don't know the constant that disappeared when they differentiated to get this one here. You get it? Okay, so this one is going to be positive 12, then over x squared, then plus the c. That is our dy dx. But we know that for stationary points like this one, negative 219, okay, dy dx will be equal to what? 0. They said the stationary point. Okay, so 12 here divided by negative 2 squared, then plus the c should be equal to 0. So this is 12, then divide by 4, we shall get a 3. So meaning c shall be equal to negative what? 3. So therefore, the expression for dy dx is going to be equal to 12, then divide by x squared, and then minus 3, as simple as that. Then part B, find the x-coordinate of the other stationary point of the curve and determine the nature of this stationary point. Like we said, for stationary points, dy dx is equal to what? 0. Also, so we shall get this one here. What we have gotten, we equate it to 0. Then I can multiply all through by x squared. That means here we'll get 12, then minus 3x squared, and this one will be equal to 0. So 12 will be equal to 3x squared. When I divide all through by 3, this one will be a 4. And then when I take the square root, then x will be equal to plus or minus 2. You see that? Now, after getting that, so the other x coordinate, remember it is plus or minus, but for this other one here, we are having the minus 2, okay? Now here we are going to take the positive 2, okay? So therefore, x here is going to be equal to positive 2. That is the x coordinate of the other stationary point. Are we there? Then what next? We are going to look at, they said the nature. We use the second derivative. So for x, which is equal to 2, what is the sign of the second derivative? We go back and check here. This one was given as negative 24 over x cubed. Negative 24 over x cubed. Now this one will be negative 24, then divide by positive 8. Then you get a negative 3. This negative 3 is less than what? 0. So since this one is less than 0, that means this stationary point is maximum. Okay? It is maximum. As simple as that. But to find the equation of the curve, of course, to get the equation of the curve, y will be equal to the integral of dy dx. Okay, and with respect to x. Now here we are having the integral. Our dy dx, we got 12 out of x squared, which I will write as 12, then x to the power of negative 2, and then minus the 3. Okay, now we increase the power by 1. So we get a negative 1, then divide by the new power. Then minus 3x, we have to put an arbitrary constant here, which disappeared when they differentiated. You get that? Okay, so y is therefore going to be equal to negative 12, then out of x, because this one can go down using rules of indices, also. Then minus 3x, then plus k. Now, there is a stationary point on this curve, which was given as negative 219. So if a point lies on the curve, that means its coordinates satisfy the equation of that curve. So therefore, if we use this negative 219, our y is a 19, and then x is a negative 2, then minus 3, then minus 2, and then plus this k here. So this one is a 6, this is 19, and this one is a positive 1. Okay, so when it crosses, it's a minus. This is a positive 6 also. When it crosses, it's a minus. So meaning our k is going to be 19 minus 12. Isn't that a 7? So k is equal to 7, meaning the equation of the curve is going to be y, which is equal to negative 12 out of x, then minus 3x, and then plus 7. As simple as that. Then part D, find the equation of the normal to the curve at the point where dy dx is equal to this and x is positive. Express your answer in the form px plus qy plus r is equal to 0, where p, q, and r are integers. Now, here on the curve, so suppose I have my curve like this, and then I also have a tangent. Is that line that meets the curve at only one point. Okay, so this is a tangent, and then the line that is perpendicular to the tangent is what we call the normal. Okay, so this is the normal, and of course this is the curve. Now, dy dx, since the gradient between any 2 points on a straight line is always constant, so the gradient of the tangent is always constant between any 2 points, but then the gradient at any point on the curve is always different. Now, when these two meet, then that means they are going to have the same gradient. So the gradient of the curve at this point of intersection here is the same as that for the tangent. So dy dx always represents the gradient of the tangent at that point of intersection. You get that? All right. Now, when we have this dy dx, which is equal to this, remember our dy dx is 12, so we don't know that point. And remember, to find the equation of any straight line, you need at least one point through which a line passes and its gradient. Okay, so gradient, the dy dx, the expression for dy dx, we have it as 12 over x squared, then minus 3. Then I'll equate to negative 9 out of what? 4. If I take the 3 here, we shall get 12 over x squared, which shall be equal to negative 9 out of 4, then plus 3. So this will give us 12 out of x squared, which is equal to, this will be 12. Now 12 minus 9, you'll get a 3. So it will be 3 out of 4. Now when we cross multiply, that means x squared, 3x squared shall be equal to 4 times 12, that will be 48. Yes, 48. And then x becomes the square root of 48 over 3, which is a 16. So plus or minus, so root of 16, that's a 4. So plus or minus what? 4. But they say that x is what? Is positive. So that means we shall take our x to be f4. Okay, now after that, dy dx is equal to this. That is the gradient of the tangent. Now gradient, okay, when x is equal to this 4, what will be y? Now we use the equation of the curve we have gotten here, so that means if you got this one wrong, there is no way you can get this correct. So negative 12, then out of 4, minus 3 times 4, then plus 7. What do we get? This is negative 3 minus 12. That will be negative 15, and then plus 7. Negative 15 plus 7, isn't that negative 8? Yes, negative 8. Okay. That is now we have gotten the coordinates of the point. You get it? Now we need to get gradient of the normal. So gradient of the normal is equal to negative 1 over gradient of the tangent, which is negative 9 out of 4. So this one will somersault, and then we have 4 out of 9. Remember, the product of the gradients of two lines which are perpendicular is always equal to negative what? 1. And the tangent is perpendicular to the what? To the normal. You get that? All right. Now we find the equation of this line. We use y minus y1, which is equal to m into x minus x1. So you have y minus, and we are using this one here, 4, and then negative 8. So y, when we say minus, that one will become a plus, and then our m is 4 over 9, then into x minus, this one is a 4. Now I don't need to open brackets here, like I multiply 4 over 9 all through. Because of the format, they told me to express my answer in. You get it? So all you can do here is to cross multiply. So when you cross multiply, you'll get 9y, then plus 72, because 8 times 9 is 72. Then now 4 times everything in here will be 4x, and then minus 16. So I can bring everything on this side, or I can take everything to this other side. Okay, so we can have now 4x, then minus 9y. Is everything on one side? Yes, then should be equal to 0. All right, so 4x minus 9y, then when this one goes this other side, we shall have negative 16 minus 72, and that is like 16 plus 72, that is 88. So it will be minus 88, which is equal to 0. As simple as that. Or you can bring these ones this side, and then you'll have negative 4x, then plus 9y, then plus 88 is equal to 0. So whichever you want. Question 10, part A. The first, second, and third terms of an AP are 4k, k squared, and then 8k respectively, where k is a non-zero constant. Roman 1, find the value of k. Now we are having the first term, which is a plus 4k, and then the second term is a plus d, which is equal to k squared, and then we also have a plus 2d, which is the third term, equaling to 8k. Now the common difference, we get the second term minus the first term. Okay, in other words, take the a here, which a is equal to 4k. Not so, by the way, pardon me here, what did I write? It is a which is equal to 4k. So this will be k squared, then minus 4k. That means when I come to this one here, I'll have a, which is 4k, then plus 2, then times d, which is k squared minus 4k. Then this one is equal to 8k. So do you see that the equation I get is in terms of k only? Okay, now let's open the brackets. So this is 4k, then plus 2k squared minus 8k. Okay, then I can bring this 8k here, then it's equal to 0. So here we have 2k squared, and then we are going to have negative 16k, then plus 4k. That will be a negative 12k, which is equal to 0. and 2k here is common. That means we shall have k here and then minus 6 here. So when I equate this one to 0, then k will be equal to 0. And when I equate this one to 0, then k will be equal to 6. And of course, you said k is a non-zero constant, so you cannot take it to be 0. So k is therefore going to be equal to a 6. As simple as that. Then next, they are saying find the sum of the first 20 terms of the progression. Now we need to find the first term. So the first term is given as 4k. So we shall have 4, then times the k, which is a 6, and this one gives us 24. Then the common difference, I wrote here, it can be the third term minus the second term or the second term minus the first term. But using this one that I'm having here, the second term minus the first term, we have k squared minus 4k. So k squared minus 4k. This is 36 minus 24. That one must give us a 12. Okay. Now, they said the sum of the first 20 terms. We know that sum of the first n terms of an AP, that is n over 2 into 2a, then plus n minus 1d. All right, so our n, s of 20, this one will be 20 out of 2, then 2 times our a is 24, then plus. This is 20 minus 1, that will be 19, then times, this is 12 here. You see? So this one will be 10 in here, and then this is 48, then plus 19 times 12, 228. So altogether, what do we get? 10 into 48, then plus 228. We get 2760, 2760. As simple as that. Part B, the fourth and sixth terms of a GP are 36 and 6 respectively. The common ratio of the progression is positive. That means there is a possibility of you getting two values of the common ratio, one being positive and then the other one negative. Find the sum to infinity of the progression. Give your answer in this format here, where a, b, and c are integers. Okay, so we are given the fourth term, that is ar cubed. Ar cubed is equal to 36. And then we are also given ar power 5, which is equal to 6. That is the sixth term. Okay, so I can say ar power 5, then divide by ar cubed. This one will give me 6 out of 36. Of course, the a will disappear, then r here becomes a square. Okay, it is r squared 5 minus the 3. Then this one is equal to 1 over 6. So what does this one mean? Our r is equal to 1 out of root of 6. And it is positive. We shall have plus or minus. But since r is positive, then r will be equal to 1 over root of 6. Okay. Then after this one here, we are going to get our a. How do we get a? Therefore, a, remember, for sum to infinity, it is a out of 1 minus r. R, we have it. Then how about a? So I can substitute in any of them. If I substitute here, a is going to be equal to 36 out of r cubed. And r is 1 over root of 6. Then I cube it. Okay? So what are we going to have here? Root of 6 cubed is going to be root of 6 times root of 6. Then times what? Root of 6. This one here is going to give me a 6, root of 6. Okay, so we shall get here 36, then times, out of, this one is going to be 1, then over 6 root of 6. And then this thing becomes 36, then times 6 root of 6. You see? Now, 36 times 6, that is like 6 cubed, which is 216. Okay. So our a is equal to 216, then root of 6. I also keep that one there. Now sum to infinity is given by a out of 1 minus what? R. Now our a is 216 root of 6. Then we divide by our 1, then minus r is 1 over root of 6. What I can say is just to multiply the denominator and numerator by root of 6. You see that? When I do so, I'll get 216 times root of 6 times root of 6. That will be a 6. And then down here, we shall have root of 6. And then minus this one times this, you'll get a 1. Not so. So what is 216 times 6? 216 times 6. That is 1296. So that means I'll have my answer as 1296, then out of root of 6 minus 1. That is that. I think this is the format they told us, because it is a, then out of root of b. So our b is a 6, our c is a 1. Not so? Yes. And then our a is 1296. Question 11 is coming from functions part A. Express x squared plus 2x plus 2 in the form x plus a bracket squared plus b, where a and b are integers. There are two ways you can do this. Choose the one that is simpler for you. First is completing squares, just right away. So x squared plus 4x plus 2. Here what we do, you get, first make sure that the coefficient of x squared is a 1. So that one is already 1. Then we got the coefficient of of x here, which is a 4. We divide it by 2. Then we shall get a 2, right? It's a positive 2, so we put that positive 2 here. We put it in brackets with x, and then we square. Then we pop this 2 out, and we square it as a minus here. Then we shall add on this 2. This whole thing here is this, okay? Then plus the 2. So we can simplify this, and we say x plus 2. And of course, this is minus 4, then plus 2. And this one is going to be a negative 2 here. So that is that. Someone may ask, why do we divide by 2? We put it here, then we pop it out as a square. This is what we do. Suppose I have x plus b here, squared. And then I expand it, okay? Let me just say this one is a reference, okay? This one will be x squared, then plus 2bx, then plus what? B squared. Now I need a side to have only x's, all right? So take this one, this other side. We shall have x plus b squared, then minus b squared. Then this one shall be equal to x squared plus 2bx. You see that? Now, do you see that the 2b we are having here, when we divide it by 2, that is exactly what we have here and also here. You see that? So that is what we have gotten. This 2b here, you divide it by 2, you put it inside here with the x, and then you pop it out here. A minus is there because when this one goes this other side, it changes the sign. So that is what we do. That's why we have this. Alternatively, if that one is a problem to you, you can expand and then equate coefficients. So x squared then plus 4x plus 2. This one is the same as x plus a, then squared, and then plus b. So you can have x squared plus 4x plus 2. And then here, when you expand this, it is going to be x squared, then plus 2ax, then plus a squared, and then plus b. Okay? Now we equate coefficients. So the coefficient of x squared here is a 1, as the same as this one here. Then the coefficient of x here is a 4, but then here it is 2a. So I'll equate it to 2a. That means a is equal to what? to 2 when you divide all through by 2. And then the constant here, the 2, then is equal to the constant part. This is all the constant part without the x. So we shall have a squared then plus b. So meaning our b is going to be equal to 2, then minus our a is already 2. So we shall have 2 then squared. That is 2 minus 4. And this one gives us a negative 2, right? Then you can smartly write that x squared plus 4x minus 2, this one is the same as, you substitute in this one here, so there is x, then our a is a positive 2, and then our b is a minus 2 here, but this one is squared. As simple as that. Then the functions f and g are defined as follows. This is a quadratic, this one is linear, and then their domains are here. B Roman 1, find an expression for the inverse of the function. Now, you cannot find inverse of a quadratic expression unless you express it in the completed square format. So if you look very well here, you can see that what is given here is exactly what they have given us in part A here. Okay, so I'll take my f of x to be that x plus 2 squared and minus the 2 here. Okay, so if the inverse of the x is equal to y, then that means that if I take the f this other side, I'll have x which is equal to f of what? Y. So x will be equal to, where there is y, then we put, where there is x, we put the what? The y. So we shall have y plus 2, then squared, then minus 2, and then what we are left with is to make y the subject of the formula. So bring this 2 here, it becomes a plus, so you have x plus 2, which is equal to y, then plus 2 squared. And then we take the square root on both sides, so that will be the square root of x plus 2. But whenever you take a square root, you have plus or what? Minus. And then this will be y plus 2. So that means y here is going to be equal to, take this 2 here, it is going to become a negative, then plus or minus root of x plus 2. So that means that the inverse of this function is going to be equal to negative 2. And then here we have x plus 2. Now, if you put plus or minus here, you are going to get it wrong. Okay? Because a function is said to have an inverse if it is 1 to 1. Are we there? So you are supposed to choose one of these values, one of these signs here. But to avoid wasting time, always look at the domain given. The domain is negative 2. Okay? The domain is, x is less than or equal to negative 2. When you look at this one, when we sketch, it is a U-shaped curve. Right from here, the turning point is going to be, you get this one equated to 0, so the x coordinate is going to be a negative 2. And then there is a negative 2 here, which gives you the y coordinate. Okay, so to make the function 1-to-1, because this one here is not a 1-to-1 function, it is 2x values here, they are giving to one y value. You get it? X1, then x2, they give this one y value. So this one, we call it a many-to-one function. And for that case, it is not a 1-to-1. But the one that has an inverse must be 1-to-1. So we have to either choose the left side of the turning point, then the function there becomes 1-to-1, because each value of x gives one value of y. Each value of x gives one value of y. You see that? So we either choose the left side or the right side. Are we there? Now, for this case, when you look at what is given here, we are looking at x values that are less than or equal to negative 2. So that is the left side, okay? We are considering this other side. So because we are considering the left side, then you consider the sign you have gotten here as a minus. If we were considering the side which is to the right of the turning point, for example, it is this way, then that means we would take the plus, okay? As simple as that. So this one here is going to be our inverse of the function, you see? But I can prove this one for you here. Why I've taken that one there, okay? First of all, the x coordinates we are using are less than or equal to -2. So I can use, let's say x is equal to -3. So what is f of -3? When I substitute in here, I'll get -3 plus 2. That is a square, then minus 2. What do you get here? It's a -1, then square, that is a 1, minus 2, then we shall get a -1. Okay? Now remember, we have x here, and then a function acts on that x to give you f of x. Are we there? Then the function that undoes what f has done is the inverse. So that means the domain of this f, this is the domain of the f, then this is the range. What we put in the function is the domain. What comes out is the range. Now, since this is the inverse of the function, then this one is going to be its range. Okay? I mean its domain, and then what comes out here is going to be its range. Okay, now leaving that aside, what is the inverse of what we have gotten here? We want to go back, so I'll put -1. Now I'm going to put in this expression here. So we have -2, then there is the square root of -1 plus 2. I'm going to leave this one blank, okay? Then we'll look for the sign that goes there. So first of all, this one is 2 minus 1, you get a 1. Square root of 1 is a 1. Now my question is, do we put a plus here to get a -3? When you put a plus here, you're going to get what? You are going to get a -1. So you are not getting back to this one here. But if we put a negative sign, then this one will give us this -3 here. You see that? So that is why we are taking a negative here rather than the positive. Do you understand that? So always just look at the domain given. If the domain points us to the left of the turning point of that quadratic curve, then we take the minus sign when it comes to the inverse of a function here. And then if the domain points us to the right of the turning point, then you take the plus what? Sign here. As simple as that. But never put these two, because when you put them here, this is no longer a one-to-one function. Roman 2, find an expression for gf then inverse of x. There is a difference here. Okay, there's a difference between these two. There is a point, there is a time they can give you something like this. Okay, that means they are composing the inverse of f into the g. So this is the same as that. Are we there? Then there is also where they can give you g, then they put the inverse here, then f of x. That means they are composing f of x into the g inverse. So that is the one there. Okay. Then here we are seeing these two put together, g, f, then they put them in brackets, and then they put this. Then that means we are getting the inverse of the g of f. So you first get the g f of x, then after you get its inverse. Let me hope I've made necessary noise. Okay, now let's start. We need to get g f of x. So first of all, what is g of x? G of x was given by -x minus 4 minus x minus 4. Then g, no, f of x is x minus, was it x plus 2? Yes, squared, then minus what? 2. So when we are getting the g inverse, okay, we are going to get, no, before that, we are getting g f of x. So g f of x here is going to be, you go to the g, you are putting f of x wherever there is x, so you are getting negative f of x. It is taking the place of the x here, then minus the 4. So we can have negative of this x plus 2 squared, okay, then minus 2, and then there is a minus 4. So when we open the brackets, we shall have negative of x plus 2 squared, and then plus the 2, then minus the 4, and this will be minus x plus 2 squared, and then minus the 2. Okay, then after that, we need now to find, remember, even this one is quadratic. You could actually use f of x, which was x squared. What was it? It was x squared plus 4x plus 2. But again, you will end up with a quadratic. So you have to use the completed square format to find the inverse of that function. You see that? So suppose the GF inverse of x, let's say, is equal to y. That means when I take the inverse to this other side, then our x is going to be equal to GF of y. So we shall have x, which is equal to, where there is x, then I'm going to put what? A y. So we shall have negative, then y plus 2 squared minus 2. So take this negative 2 here. Or actually, let me first take this one, this other side, such that it becomes a positive. Are we there? So we shall have y plus 2 squared. Then take the x this other side. It will become a negative. Okay? And then we also have the minus 2 there. Then we take the square root of that. So it will be y plus 2, which is equal to plus or minus the square root of, I can actually pull out the negative here, and then I have x plus 2. You see that? And then from there, y is going to be equal to the negative 2, then plus or minus the root of that. And also see that we are having, actually, when you look at this one here, it's a negative, and you cannot have square root of a negative. So that means the values of x that we are using in here, when we substitute everything here, it should turn out to be a negative, such that a negative multiplies a negative to get a positive. You get that? So that's why they said x is less than or equal to that negative 2. You get that? So when we begin with negative 2, this one will be a 0. You see that? And then those values that are less than negative 2, let's say we put negative 3 here, then plus 2, we shall get a negative here with a negative, then we can be in position to get that one, square root. So we are considering the negative values of x, okay? And for this case, we shall get our GF, then inverse of x is going to be equal to negative 2, then again minus, then the square root of negative x plus 2, and then from here we get this as our answer. As simple as that. This has been it for the second part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even give us a subscription. See you in the next videos.